Oh my gosh, it's still calling. Why is it still calling?
It did that with me last night too.
What in the
All
world?
right. Are we all back in?
Oh, yeah. I'm gonna freaking shoot that thing.
Are you still getting the?
Oh my gosh, I'm gonna leave really quick. What? Hang on. Just wait.
I think you're back. I think you're
Hang
good.
on. I think I fixed it. Did I fix it?
Yeah,
Yeah.
not going off.
Okay. Okay, hold on. Wait. So, Jessica, what did you get for the second coordinate?
I got 4 and then 5 pi over 6.
5 pi over 6. Okay.
Okay.
Why did you guys get? So for some reason, I don't know if it's just my calculator making a mistake, but when I did inverse tangent of 2 over -2 square root of 3, I got negative pi thirds. And then when I added pi to that, I got the 2 pi over 3.
Well, that's what I got when I accidentally, I did that and I had a parenthesis in the wrong spot and I got negative pi thirds. Went back and made sure I put the top and bottom in parentheses and then I got the 5 pi sixths. What calculator you use?
I just use the TIA 36 Pro because that's what we'll be using on the exams.
Is there a way on that one to convert to exact and make it give you an answer in pi?
Yeah.
How do you do that?
Here, I'll show you. Okay, so if I put the top and bottom of the fraction in parentheses, then I get negative pi 6. And when I add pi, it gives me 5 pi 6. Okay, sweet. Okay, here, hang on, let me. I'll show you. Oh my gosh, what did I just do? 5 pi. Oh, whatever. Yeah. Okay. So
Not quite so.
there's
Okay.
That's the enter key, right? Right above the enter key, there's a little silver button, and it has like arrows facing each direction and a squiggly equal sign. You see that?
Okay.
So if you just like that tan equation that I had, right, or that we did,
Yeah.
if you just take the equation and then push that button, little arrow keys will come up, and then press enter. It'll give you an exact answer. So.
Okay, so once I got the arrow keys, what do I do?
So just like this, you just press enter, and it'll give you an exact answer.
Awesome. Thank you.
I know, right? I had to look that up actually the other day. I was like, what is this?
Yeah. Yeah. Sweet.
What is that?
So you guys got the next one done?
I actually didn't. You guys can move along if you want. I'm sorry. I
Yeah, I'm still working on that one. I don't know why I'm having so much. Keep getting these weird answers. Okay.
Did you just take the inverse tan of 1? You can, can't you?
The inverse tangent. Sorry, what'd you say? Inverse tangent 1?
Yeah, you can do that.
All right. Okay. All right. Oh shoot! I should press both of these. Because that gave me a pi force, and then I need to add a pi. Oh, 5. Did you guys get 6 and 5 pi fourths?
For third one? Yeah.
Yes. Oh, sweet. Look at that. I can math, guys.
So, and why is it? This is what I don't get. Why is it? When do we know if it's 5 pi fourths or just pi fourths?
So, like, you want to make sure that your coordinate is in the same quadrant as, like, the original coordinate. So, like, the negative square root of 3, or the negative 3 square root of 2, negative 3 square root of 2 is in the lower left-hand quadrant. So then we know that the angle has to be in that quadrant too. So it can't be the other one.
Okay.
There was the video where he taught us about this. He made a nice little list of basically the circumstances. And it was really, I think it was within the first lesson. But one of the videos he kind of writes down like a scenario is like if x is greater than 0, then it's just inverse tan of y over x. If x is less than 0, then it's inverse tan of y over x plus pi. And then he gave like 2 other scenarios where you could do.
Okay. I might have to add that to the summary sheet.
Yeah.
How are you guys doing on those summary sheets, by the way?
I got an A on my last one. I was so proud of myself.
Yeah, I don't know if you really looked super close at them.
I got they're only worth 1% of the grade, but I just run out of space. And then he said
Yeah.
stuff.
Yeah, so I don't even I honestly don't care anymore. I just upload 4 pages. Like, I'm not even kidding. I upload
4 pages?
I upload everything I have, and then I'm just like, boom. Here's my stuff.
Because the quiz says you can use 1-page front and back summaries. So I'm trying to stick it to.
Right.
I get like all of my notes on like front and back, but then like all of my example problems, like I have those on like the extra pages.
Okay. Submit more.
Yeah, I'm just like, look. And organization. I guess I wasn't like, I thought I was really organized, but I don't think I was organized the way he wants it to be organized. So I tried to organize it differently, and then I got an A. And I was like, okay, all right. And y'all got 6 in pi thirds for the first one, right? I'm sorry, that's a good.
Yes.
Okay.
Or at least I did.
I trust you. Complete faith. Okay. Choose the correct. Oh, I hate these.
All right. And then what'd you guys get for the last for C? Sorry, real quick.
6 and then 5 pi over 4.
Perfect. Okay. Beautiful. 5 over 4. Choose the correct graph below.
So on number 2, I got the flower looking thing that has 3 petals, and the one is like intersecting the y-axis, like it's straight up, and then the other 2 are like in between the x and the y-axis.
Oh.
Okay.
Yeah. So it's got like the little mini version of itself inside of it.
Yep.
Uh-huh.
And then straight up and then down and to the right, like at 45 degrees.
Yeah.
Yep. Perfect. Sweet. All right.
Do you guys do the whole thing where you draw it out on like a regular graph first, and then you do like the other graph?
I do, yeah.
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 I do too. I think it just takes me a while to do it.
Yeah.
I'm not good at like drawing out those graphs super quick.
No, these take forever.
Oh, I hated this one.
Is there one like this in the homework?
Yeah, on the homework that was due last night.
Oh, so I must have done it. I'm so like, whatever class I'm working on is the only thing that I can remember at that moment.
No, that's weird.
So for the first part of 3, did you get A?
So for me, it's D.
Which one is that?
It's the one that has like the 2. I can't remember what those are called, lumoids or whatever.
Lemniscape
Yeah,
or lexicon. I don't know.
yeah, I can't remember what's what. It's got like the 2 folded over each other, and it almost makes it look like an infinity sign in the middle.
Okay, yeah, like up and down.
Yep.
And then it has like a circle on the outside of it. Is it that one, or is it just a simpler one?
For me, it's like kind of the simpler one.
I know that's relative in this.
Yeah.
Gotcha.
So it's not the one with the circles like that actually loop around the x-axis. The loops are like above and below the x-axis, but on the y-axis, like symmetric to the y-axis.
Right. Okay. And then it doesn't have any circles around that, right?
No, I don't think so.
Because there's one on here that's like super busy that has like, it looks like one circle and like another circle, and then what you're describing on in the middle.
Yeah.
Yeah.
Okay. So it's not. Yeah. Good deal.
So I have a question. Just looking at these next 3 really quick. Am I right in thinking, do we all have cosine 3 theta, cosine 4 theta, and cosine 5 theta?
Yeah.
Okay, so can't we just say cosine 3 theta has to have 3 loops, and because it's an odd function, and cosine 4 theta has to have 8 because it's an even function? And then the cosine 5 theta has 5 loops because we're back to the odd function. So we can just look at the multiplier of theta and figure out how many loops. Is that how you guys do this?
I do not know.
I was actually when I was doing the homework problem, I was trying to figure if that out like actually works, because like it seemed like it did for a second, but then it wasn't jumping as sequentially as this one is here. It was jumping like, on the homework it did like 1/2 and then like 5 and then like 7 and then like something else. Like it was really different. I was like, is that actually making sense?
I think it applies as long as you have nothing but the sine function and theta.
Right. Well, so it does work for 3 theta, cosine 3 theta. I double checked and graphed it in Mathematica too. And I am getting like the 3 petals, and then the next one I get the 8 petals.
Okay.
I think that makes sense. I don't know if this works for those cases or if it works for any case. I mean, I would think so.
I might look more into that because I remember being told some rules about that, but I don't remember them.
Right, I got you.
Yeah. Okay.
Oh yeah, this one. Ugh.
That just hurt me a little bit when I saw that problem.
Wait,
So wait, are you down to 4?
Oh, yeah. Cardioids, man. What the freak?
Okay, well, I am still on number 3.
Oh, okay.
Did you hear how I did it?
What?
Did you hear how I was saying I did it?
Yeah, well, kind of. You said that the number on the inside of the cosine function is how many petals it has.
Yeah.
Is that right?
I think it is.
I tested it in Mathematica and it worked.
And it worked for all of them?
For all of them,
So
yes.
if it's an even multiplier, then it's 2 times.
Yep.
so you should have like 8 petals on the cosine 4 theta.
The cosine 4,
But if
yep.
it's an odd multiplier, then it's just itself. So it's 3 petals in the 3.
We were going to look up later, or I'm going to look it up later and see what the rules are for that, like when it doesn't apply. Like what, if you do certain things to it, then it no longer applies. But
Okay, so if it's even, you double the number to get the number of petals. And if it's odd, that's just how many petals it has.
Yeah.
Yeah.
At least it worked in these 3 cases. So
and maybe it's only for
Okay.
roses. I can't remember.
could be that.
I don't remember the rules. Yeah.
Oh, this is gross.
Isn't it?
I'm seriously thinking about investing in Chegg.
I've got an account if you want access.
Do you really? I tried
Yeah.
it for a little while and I just never used it, but now I feel like I would use it a ton. I don't know why.
I mean, like this one, physics and stats, like it's so worth it.
Yeah, that's true. How much is it?
The
Is
only-
it $20 a month?
15. It's the only way to know you're actually learning.
It's true. It's good to check your answers instead of just get a quiz back and say, "Oh, I missed every question."
Yeah, because if you're off and you just missed everything,
Yeah, sucks.
I just got 0. So those are called cardioids. Okay. So those are what those are. Oh.
Oh, that one's like starting.
So we can do 2, 0, 2, I. So are we, are we all on problem 4 now?
Yeah.
Yeah.
Okay, so can we do bounds of 0 to pi pi halves? And then just say that we're gonna have 4 shapes, so we can do we can multiply the integral by 2. I'm not sure we all do this the same.
No, you're good, man. I think that'd work. I'm trying to do, okay, so
So I need to do.
Area shaded. Okay.
Are y'all just using like applications to map these out really quick?
I just barely graphed them using my 89.
See, that's what like
Yeah.
I want to do that, but I'm so worried about when I take the exam this week, you know?
Yeah.
That's exactly what I meant when I kind of texted, because it's like I can't see these. Like,
Yeah. Like
Yeah.
I can't do these as fast as he does them, so that's kind of the one thing I'm like worried about.
Otherwise, I have to plot it out.
Yeah.
right.
So what I do, I kind of plot it out, and I'm thinking, oh, this is starting to do that one thing that looked like a whatever, and then I guess at what it's supposed to look like.
Right. I've never done an off-campus, like I've never had a proctored exam. Do you take your own computer? Or do you just use the computer there?
It's a write-on test.
Oh, okay. So they print them out then.
Yeah.
Gotcha. So you don't even mess with the computer.
Right. Now you're on campus though, aren't you?
No, I'm in Blackfoot, so I'm like 50 miles away. So
Oh,
I'm gonna
okay.
I'm gonna go take it at a library. But
And are you on campus, Jessica?
I live in Teton, which is like 15 minutes from campus.
Oh, that's right.
I'm gonna take mine at the testing center.
Yeah. Okay.
okay, the region has 4-way symmetry.
So how do we find the bounds where, like, I'm trying to find the bounds by setting the two equations equal to each other to see where they meet and finding what theta values they are. But I'm getting like cosine theta equals negative cosine theta. Oh, wait, I guess I can just add, oh, I can add that over. So,
Yeah, it'd be nice if we could use Mathematica on the test, and
yeah.
I mean, even for just setting those bounds equal.
Mhm.
Yeah. So all you did, Jessica, was just set the two equations equal to each other?
Yeah, that's what I did on some of the homework problems, but like I'm just not right now I'm having a hard time getting it to work.
I got you.
Doesn't it just come?
So go ahead.
No, never mind. Go ahead.
I was gonna say if you graphed it, you should be able to. This one's nice because it looks like it starts coming out from the origin, and then it meets up on the y-axis.
So that would be halves, right?
Of 0 to pi halves.
And then we just times that by 4.
Yeah, but because we're doing isn't the equation? It's like 1/2 r squared or whatever.
Oh, I'd have to look it up.
So it's the integral of 1/2 r squared d theta.
Okay.
So if you're going to integrate, if you're going to have a integration of 1/2, you just pull that out. So it's really 4/2 for this one. So I multiplied it by 2.
All right.
You said we were going to go from 0 to pi halves.
Yes.
And so do we have to integrate? Do we have to integrate like each of those separately within that bounds? Right.
Well, we would, except in this case, they appear as if they're all the same size area. So if we get the area of one of them, we can multiply that by 4.
Oh yeah, which is actually multiplying it by 2 because it's already multiplied by half.
Yeah.
That's what you're saying. Sorry, I totally.
No, it's all good.
Not be.
So I found out this week, like I'm in an engineering team that we're like working on a project. Anyways, like 2 of the guys in there both tutor 215. So I spent a lot of time this week with 215 tutors.
Nice.
I still can't do algebra, but
There you go. Theta equals pi.
Let me try to name these shapes.
I don't know. I wanted that too. So are you just taking the integral right now, or have you already finished that?
I did the integral. I have an answer, and I'm trying to do it again because it just seems weird.
What'd you get?
I got that it's like 9. There's like 18 plus 9 pi. So if you factor it out, like for some reason the homework factored them out. So 9 times 2 plus pi.
I got you.
So I factored the 9s out to outside, so I had 18 times the integral of 1 plus cosine theta d theta from 0 to pi halves. Is that what you were doing? Is that what we set up?
Yeah, so when you put in your equation, how did you determine what line to use?
So that's where, I mean, that's like, just from, I thought from what you were saying, like since they are.
Okay. So
Like, I thought
I'm not 100% positive, like when you put the R in, like if you use 9 1 minus cosine theta, or if you use the 1 plus cosine theta. But I think because I did 0 to pi halves, that I have to use the minus, because that's the one on the left side of the y-axis.
it's on the left.
Yeah, 9 times 1 minus cosine theta is mostly on the left side of the.
So are you saying
It's
what?
still-
Are you saying what overlaps is on the right side of the y-axis?
How about I like? Do you guys think it'd be all right if I like put the graph itself in Desmos and then shared the screen? Graph.
Yeah.
Okay.
Because to
Do
me,
that.
it just makes sense to like use whichever equation is holding what's like being intercepted mostly. So like if what's being overlapped is like mostly on the right side within, or is like 0 to 0 to pi halves, and that's like on the right.
Okay.
That's,
I'm trying to share a screen. Can you see my screen?
yeah.
Okay, so I just put those in Desmos. Those are the two equations, right?
Yeah.
So I feel like if we're going from 0 to pi halves, that is this guy.
Yeah, that's okay.
Second,
That makes
right
sense.
here.
Yeah, that makes sense.
So then I use this line's equation. And that's I'm pretty sure that's right, but I'm not positive. That I don't think we want to use this line's equation because we're integrating from here to there.
No, I think you're right. Yeah, that makes sense. Yeah, that makes sense. I just didn't.
So-
I didn't know which was which, so I was like.
So for your answer, did you get 81 halves times 3 pi minus 8?
I am actually. Give me 1 second. I'm gonna make sure I did it right because I used.
So I didn't. I just got 9 times 2 plus pi.
9 times 2 plus pi?
Yeah, that in parentheses, and then 9 multiply it both. So it could be like 18 plus 9 pi.
Yeah.
So when you do this, now, when you set up your that R equation, do you FOIL it all through? Is that how you handle the square?
Yeah.
Okay. And then you factor out. So we can use the TI 36, right? Because that's how I'm solving my integral. Because the TI,
or
the 36 Pro does definite. I'm gonna cancel the screen share. Stop sharing. Okay. Just put the integral into the TI 36 with the definite integral button there.
Okay.
That's how I do it.
And did you get the same answer when you tried it again?
Yeah, as long as I'm using the right equation and we're going from 0 to pi halves.
Okay, but how do you get that to give you a non-decimal answer?
Let's see if we can just use that button that Sawyer was using.
Yeah, so I'm clicking on that and it's not changing.
Yeah, I'm noticing that too, so I'm trying to figure out.
Okay. Let me see. 1.
Let me try again.
X. X.
Um,
That's this whole thing squared. Yeah, mine's not giving me a decimal answer.
That's so weird.
okay, wait. How did you put your calculator up to the screen? That might be a lot, but just.
The problem with is there any way you're going to be able to go this way?
Yeah, just hold it still for me. Did I? Wait, hold on. Oh, shoot. Hang on. Okay. You did that, and then you had a square. I totally forgot to do that. And you didn't have to put it. Did you use the button I told you to use?
Oh, I did not.
You didn't? Okay, hang on.
And then, yeah.
Oh, hey, your cosine squared, that squared should be on the outside of the parentheses. Right now it's just 1 minus cosine squared, and it needs to be 1, like the whole 1 minus cosine thing needs to be squared.
So 1 minus cosine. So let's put it. I wish I could put these in the 89 because they're so much easier to do and see your whole screen. So 9. So that's cos. Wait, is it? No, I still have it wrong. I need this whole thing squared. No, I've done it.
Did you put in? Did you like distribute the 9 before you put that into the like?
I did not. So let's see. Is this right? Let's see. I've got. So that's right. Is that? Oh, the camera's over there. Anyway.
Hold on.
How can I make that readable?
That's good. Yeah, just keep it right there.
Yeah, you've still got the cosine squared only and not the 1 minus cosine. So you need to put a parenthesis
That's what.
the x and the 2.
It technically needs to be, yeah, the 9 technically needs to be included in that as well, because it's part of the R equation.
That's true, yeah.
I've got so many parentheses in here, I can't keep them track. So I'm about to start over.
I'm gonna distribute the 9n.
Okay. Oh, that deleted everything. Might just be easier to FOIL this out really quick. Get something like would be 81 minus 192 cosine theta plus 192 cosine. Is that what that is when you FOIL it?
81 plus 18 cosine, or sorry, yeah, minus 18 cosine theta plus 81 cosine squared theta.
Ooh. Yeah. Yeah, just FOIL that through.
Yeah, I think that might actually. So.
Ooh. So when you wow, man.
Dang, bro. Good job. Holy cow.
Did you get it, Sawyer?
No. I think I'm gonna do this by hand. I'm sorry, but I'm getting angry.
Yeah, I'm doing it again by hand to make sure.
And hey Jessica,
Mm-hmm.
it was 81 minus 18 cosine theta plus 81 cosine squared theta, right?
Yeah.
Okay. Seems legit.
And then did you take an 18 out just so you can move it out in front of the integral?
You could do that.
No, I guess that doesn't go evenly. I could take a 9 out.
Yeah.
That's like just what's the integration of 1 minus cosine theta? Because doesn't that 1 have to become a theta, and then the cosine, that if it's a negative cosine, it would have to come from a negative sign, and then that negative sign had to be squared. But if it doesn't have any number in there right now, that means that had to be over 2, because that would have reduced. That makes sense what I just said? That was just like he's weird and it doesn't make sense. Hey, couldn't we also, I don't know if this would make it easier, but couldn't we also split this up into 2 integrals? Just for,
Yeah, we could split it up into 3 integrals.
wait, 3? Really?
So do you mean 2 as in solve for theta and then solve at 0 and then subtract them?
I mean,
Is that what you
no,
mean?
so we're taking, the integral of, so 18 times the integral of 1 minus cosine theta d theta, right? That's like kind of what we're at. Can we split that up into 18 times the integral of 1 minus 18 times the integral of cosine theta d theta? Or plus the integral of negative cosine theta? Like, you know what I mean? Like when you split the integral up to like bunch of different little sections, but you can still combine them all at the very end. Does that make sense? Am I making any sense to anybody?
Yeah, as long as they're just added.
Yeah, like they're just added, but you basically just do them like the parts of it individually. Like if you're doing an integral of x squared plus x, you could do the integral of x squared plus the integral of x. You know what I mean? And then combine them at the end. Hey. Jessica, do you have an answer? Like, are you pretty confident with your answer?
Yeah, because I typed it into this one, and it gave me the decimal 57.7, and then I double checked it with my TI-89, and the 81 halves times 3 pi minus 8 is equal to the 57.7.
So the number you got on your calculator is 57.7, right?
Yeah, but then the exact answer would be 81 halves times 3 pi minus 8.
Okay. And did you get that number from like paper or from like an application or something?
So I got that from my 89, and I'm just trying to verify it with my work right now.
Okay.
Like, I'm pretty sure it's the right answer, but I get it by hand.
Yeah, no, yeah. I was gonna ask, do you happen to have like what you typed into your 36 still? Or did you use 36?
The third, yeah, I do. So let me do this. Present to everyone. I don't know if you can see that or not, though. Like, that's part of it. Can you see that?
Yeah.
And then, oh, it's not letting me go over. Here's what the end of it looks like.
Oh, okay.
Sure.
Okay. Okay, sweet. So I think, yeah, what I'm struggling with is getting that freaking parentheses.
So Jessica, you said yours was 81 over 2 or 81 halves times 3 pi minus 8?
81 halves times, yep.
Okay. Just broke that down, and I think that's the same as what I got, I think. Is this, but just side note, this is all going to be on the exam, right?
What?
Is this quiz, like this stuff, like cardioids and stuff, is it all going to be on the exam?
I think so.
Gee.
Because he said that, like, the group quizzes are for us to, like, see what we still need to study for the exam.
Yeah. Man, this one's brutal.
Yeah.
Well, I took the 8.
What's your exact answer?
81 halves times 3 pi minus 8.
Okay, that's what I got.
Okay.
So do we need to simplify that anymore? Like I got 243, like 243 halves times pi minus 324. Do we need to simplify it like that far down, or?
I don't know. I think it would be fine if we left it in parentheses, but I'm not sure.
I got you.
Yeah, I just know like the homework liked having that factored out for some weird reason. At least that's when I put them in. I got them right when they were factored out.
Okay.
I don't know. I'm getting a different answer on my calculator for some reason. I don't know if I'm figuring it wrong or what. Well,
Okay. Yeah, so your rough guesstimate, Jessica, earlier was 57.7? Like
Yeah.
Okay, gotcha. Well, I factored it out, so I might give it a shot. I gotta,
You gotta go.
yeah, I'm gonna have to go here.
Wait, what was your answer that you got? I'm sorry, like your exact answer.
So factored it out, I got 243 pi divided by 2 minus 324.
Minus 3?
324, sorry.
Oh, okay.
3 pi
Right.
over 2 minus 324. You said?
Yeah, and that's just factored out of what we got originally. Jessica got originally too. So, and didn't you get that as well?
Yeah, I got it now.
Okay. Yeah. I'm gonna try. I think. There you go. Well, I don't want to sway you one way or another,
Oh, dear.
but I think you should be good. So,
Okay.
so
Yay.
there you go. My best score so far. So that,
That's good.
Could I ask really quick before we end it? Could I ask for like, I mean, just for Jessica and Brady, since I guess Hayden, you have to go. What did y'all's integral end up looking like on paper that you put?
So I ended up integrating 2 integral from 0 to pi halves of 81 minus 18 cosine theta plus 81 cosine squared theta d theta. And then I broke the cosine squared theta into 1 plus cosine 2 theta over 2. Power reducing identity. Did you do that?
I didn't.
No, I couldn't figure it out on paper.
You couldn't figure it out on paper? Okay.
I ended up figuring out how to do it on the calculator.
Okay. But you had 2 integrals 0 to pi halves 81 minus 18 cosine? Yeah.
Mhm.
Minus 18 cosine theta is what we had earlier, and then plus 81 cosine squared theta.
Mhm.
And then the
Okay.
squared theta goes.
all right, I'm all submitted. So thanks for the help, guys. I'm gonna jet though. So
All right.
All right.
you guys would be good. I think, yeah, I think you'd be good. So,
Okay.
all right, we'll see ya. Oh, Jessica, you'll text out the link or whatever, or
Yeah.
email it or whatever.
Yeah, I will.
Okay, thanks. You're the best.
Thanks.
All right, bye.
Then you said you turned the cosine squared theta into the cosine of theta over 2.
So I turned cosine squared theta into 1 plus cosine 2 theta all over 2.
Yeah, sorry about that. And then did you distribute the 81 in?
Yeah.
So between 81 plus 81 cosine theta. Oh no, that can. Did you reduce that with the 2 underneath?
So I just left it as 81 halves plus 81 cosine 2 theta over 2. So I broke up the 1 plus into the 1 half plus cosine whatever over 2.
Oh, okay. That's 30. Okay. And then did you just go through and integrate each part individually?
Yeah.
Pretty much.
Mm-hmm.
So did you get?
What?
Sorry, I started thinking when I started speaking. So
Oh, you're good.
yeah, 2. So 2 times, and then the integral on the inside would it be? So 2 times 81 theta?
Yeah.
Minus, wait. Yeah. Oh,
Mm-hmm.
18 sine theta over
That's what I got.
sine theta and then plus 81 over 2 theta.
Yep.
Hold on. Gosh dang. 81 sine of 2 theta over 2. Is that it?
I got it over 4 because you
Oh.
have to divide by the derivative on the inside.
Okay. And then you just put in 0 to pi halves.
Yeah, I multiplied by the 2 first, though.
Yeah, okay, so you just shooted the 2 in, and then you did everything out, 0 to pi half.
Yeah.
Holy cow, that's really lame.
Mm-hmm.
Okay. I think that cosine squared, I forgot about that identity, so that was throwing me off. I was trying to like switch that out with something else. But okay, that identity is a lot easier. Okay. Fine, that's just anything. Have you all submitted your quizzes already?
I have not.
I haven't. I'm still just like on those graphs. I'm just trying to like do it the long way, I guess.
Yeah, no, I totally feel you there, Jessica. I mean, that's definitely something that I'm kind of like worried about, you know?
Mm-hmm.
Because I can like start to plot points really quickly, but I guess for me, sometimes I struggle on like just the like the graph of the function, you know, like the regular graph, not the polar graph of it. That's the one that takes me a second, because like I feel like once you see that and then you just know a few points on there, you can be like, okay, well I'm gonna be increasing here, then decreasing, and you can kind of like match
Yeah.
up, you know. But yeah, it's just like freaking that first part.
Let's see. We don't have to. Well, do you guys want to go over like quiz corrections or anything?
I haven't looked yet to see which ones I missed. Would either of you possibly be available for like a half hour if we did it like on Friday or Saturday for that? Or do you think we need to do that? I can look and see what I missed. Where is that again? Assignments?
Go to yeah.
And then I can go to feedback.
Mm-hmm.
Because I wouldn't mind just kind of taking a look at them before, in case I just did something. If I can just do it myself.
I think I just messed something up. Looks like I just made some little mistake.
Okay, no, I could ask a question really quick.
Okay.
Because I felt like I need to deal with number one, and it's number one that I missed. So,
You had a question on number 1?
yeah, I guess I don't know what he means. Like where he says indicate direction. Like if you're just transposing like two. I mean, I solved for direction because I don't know what he wants me to do. I didn't understand question 1.
So I drew like I copied you.
Do you mind sharing your screen? Or I could share mine. Either way.
Or I can share. Let's see. Let me go down and then present to everyone. Okay. Can you see that?
Yeah, that's exactly what I did.
By the way, have you guys submitted your quiz?
For 4?
Yeah. No.
Yeah,
I mean,
have.
The group quiz we just did tonight.
Oh, no, I haven't yet. I need to still type in that last answer.
Okay, yeah. But so let's see. I should be able to see your.
Oh, do you want me to?
Yeah.
So this is here. I'm finishing it right now.
Oh, Okay.
Yeah.
So he just wants me to label it.
I'm guessing.
Okay.
So.
Mhm.
Basically, you just have to remember that you try to draw them as representative of like their actual direction and magnitude as well.
Yeah.
That's
So
what-
I'll just share mine.
Okay, let me unshare mine. Oh, come on.
Oh, I never show up. Here, where screen share? No, share.
Yeah, see, Jessica, I don't know if you can see on mine. Like, I missed number 3 is the only one I missed, and I don't know what I did wrong.
Sorry.
Maybe I just got the equation wrong. I don't know.
Okay, which Sawyer? You're asking about yours?
Yeah.
Okay, so yeah, on 3A, I got 7/15 and 7/30 and 7/6 for my vector. So you did, let's see, you did U. Okay, so the formula for the projection of V onto U,
Yeah.
or U onto V, whatever, is U dot V over the magnet or the norm, the length of V times the length of V times the vector V. And it looks like you just did U over something
The length
times
of
V. Yeah, so you need to do U dot V over the length of V times the length of V, and then times the vector.
Okay, so you said, I'm sorry, I'm going to ask one more time. So the length, it's over the length of V times the length of V again. So it's the length of V squared.
Yeah.
And then times, when you say the vector, you mean just times V itself, like the original V, or times like the product, like the U dot V?
Can you see mine? Like I have the formula on there.
Hang on. Maybe could you lower it just a little bit? Okay. Oh my gosh, I kind of see it. Oh,
Now it's getting
Try
fuzzy.
tilting
I
the
know.
top up a little bit. The other way, sorry.
oh my gosh, this is so unfair. I'm like so close to knowledge. Okay, wait, raise it up a little bit. Hold on, we're almost there, guys. Oh, that's okay. I understand everything now. That's right. I do remember that equation now. Okay, thank you.
Okay. So now, can you click over and see mine?
Yeah.
We need
pull it back up again.
We are in desperate need.
I'm so confused on what window I have stuff.
Brady's. Brady, you want to present yours?
Yeah, I'm trying to.
Okay, there we go.
There it is. Okay. Can you see that? Can you see my screen now?
Or no?
Oh,
you guys see that?
Whoa. Yeah. I don't know what's going on. Okay, let me see.
We have too many weird things going on.
Okay, so now I see Brady's.
Yeah, if you just click on his little subtitle thing, it won't do that. Hang on, I'm gonna stop. Oh gosh.
Okay. So is that my test now? Can you see it now?
I just see a black bar. Is that what you see, Jessica?
Yeah, I just see a black bar as well.
So I think I'm sharing the wrong thing. Okay, so stop sharing.
Oh, now I'm watching myself. Okay. I was like, whoa, I'm gorgeous. Okay.
Okay, so now can you see my test?
Oh, yeah. That's
So
what's up.
on those ones you were just talking about, like 3A, do I just need to FOIL that through? Is that the only thing I did wrong?
Say that again.
So 3A, you got 7/15
Uh-huh.
and like 7/30.
Uh-huh.
and 7 over
6.
6. So I'm just factored out.
Yeah, and yours isn't it's not in vector component form. Like he wants the little pointy brackets to show that it's a vector and not just a point.
Okay. So then if we look at number 1, like I just copied U, TU, and V. And then I actually solved for direction. So all I need to do to get those 8 points is draw a line across the bottom of that.
Yep.
Yeah.
And that's your 2 plus V vector.
Okay. So we didn't solve for direction. You guys didn't actually solve for anything, right? The equation for direction and.
I think direction, you just wanted an arrow showing which way the new vector was going.
Yeah.
That's brutal grading.
That's the other thing too, though, is also whenever it's subtraction, it's supposed to be tail to tail.
Mm-hmm.
Okay.
You have that you should have your U vector going like on part B. Yeah, you should have it just going straight up like it's going, but then you should draw U coming from its tail, so their tails are meeting.
Okay.
You have like one going. What is it? It's one going from the top to the bottom because it's V minus U. And so you
Okay, and then
always,
so the direction kind of like
yeah, like the direction should be, you should basically connect those arrows, you know? You should connect them by putting the tail of V minus U on what you're subtracting and the head of it on what you're subtracting from.
So I drew part A right, and then without the direction.
Yeah.
Okay. So then
Alright, just graded.
I just need to make that a vector.
Yeah.
On 7.
7. Does that look like what yours is if I multiply through?
I got 15, 8, and 5, and he marked it right.
Okay.
That's what I got too.
Okay, so he
Yeah,
doesn't care what the magnitude is. He just wants something perpendicular.
Mhm.
Yeah, and you don't need like the I, the J, or the K. You just need 15, 8, and 5.
Okay. Okay. All right, that's. I felt like I knew how to do it. Did the wrong thing.
I'm still really scared of graphs, Jessica.
Yeah, I do.
I'm just hoping it has something like really similar, and then it's not, you know.
Mm-hmm.
Yeah.
Okay, I think I'm just gonna submit this.
Yeah. Okay.
Yeah.
Sounds good. Yeah. Submitted. I'm submitting it. Oh. Oh shoot. Oh
What?
no. Nothing. Never mind. I'll let you submit yours first, and then we can. Yeah.
Okay.
I'm sorry. I shouldn't have reacted that way.
I'm just making sure I like answered all the questions because
No. Yeah. I just.
I didn't not answer a question. Right. That's got that. Answered
Guys,
that.
I'm gonna be so embarrassed when quiz 4 comes around because I think I did the equations right, but I straight up just like biffed on the graphs. Like I just like had a huge mind fart and I could not remember. I was like, why am I just I don't know. I don't know what to tell you all, so I'm just gonna formally apologize for that right now. I honestly don't know like what.
So what did you guys? Have you submitted?
I did, yeah.
You submit for 1B.
What did I put for 1B?
Yeah.
Let me go back to it.
Wasn't it 4, 5 pi over 6?
Yeah. So I forgot. Even though we talked about adding pi, I forgot to change my answers and add pi.
Oh my gosh, dude.
But then
Bro.
on 6, C, it was 6 and then 5 pi over 4.
Yeah. 6, 5 pi over 4.
Yep.
I put like as a mixed fraction. 5 4.
Dang.
And that's so that's the same thing.
So is the homework that's due tomorrow, is it a lot of like what we did on number 4, or is it like more calm than that?
It was a lot of. Whoa.
What?
Are you guys hearing demonic from your computer?
No?
Oh, okay. Just mine.
I can.
Yeah, the homework was a lot of finding the area and then finding the length of the curves.
Okay. And that's just really using the equations, right, that he gave us?
What?
That's just using like the equations that he gave us, really, right?
Yeah.
I mean, I think I've done I've done the first 2 or 3. I just. So when are you guys taking the exam?
Never. Putting it off. Like,
Yeah, I think I'll probably take mine Friday or Saturday.
Is anyone else kind of terrified?
yeah, I'm a bit worried about it because they're graded so heavily.
Yeah, I'm thoroughly terrified.
I just feel like there's a ton to memorize because like we can't use any like note page and
Yeah.
like Taylor polynomials and then the formulas for area of the curves and the length of the curves and I don't know, and the identities.
Yeah, like, I mean, when you're on campus, you can use all of that. You can use a TI-89 calculator. You can, like, bring in a, like, sheet of note paper, you know? Like, I'm like, bro. Come on now.
Yeah.
Where do we get the instructor's email?
I don't really pay attention.
I just in my BYUI email, I just start typing Pete Soleil or whatever, and he comes up.
Yeah, you can find them if you go to. I do know if you go the way I found them before. So if you're on like, you know, your main iLearn page, and you go to.
But it comes up if I just start typing his name.
Okay, yeah, I was just there's somewhere on. I found it before. There's somewhere on like your iLearn page where you can click and you can go see like the entire class and you can go to him. Because I checked like my personal email a lot more, so I email him from that one. That's for me. I think I might have to take the exam on Friday, but would you guys be opposed to having like a study group session ever? Like,
I'm always up for it. I mean, if I can find
I would
time.
not be opposed to that.
okay, all right,
Yeah.
cool, sweet. So yeah, I'd enjoy it. I think it'd be beneficial.
Okay. Well,
You guys just figure out over text a time, and I should be able to make it work.
Okay.
sounds good. All right. Anything else before I shut
No.
this down?
Not unless you want to help me with an engineering test I have to do.
Oh yeah, I don't think I could help you with that.
Alrighty.
All right.
Well, I'm good. Thank you.
All right. Thanks
Okay.
so much.
Thanks, guys. See ya.
Yeah.